Okay, so we've encountered additive inverses before. The definition of additive inverse is as follows. For any rational number a over b, there exists a negative a over b, or the opposite of a over b, such that if we add these two expressions together, they end up canceling each other out and we get 0. Okay, so in other words, for any rational number that we have, we can find an opposite of it and the opposite is defined as such that if we add it to it, we cancel it out. So for example, if I have 3/5 or negative 5/11 or 4.5, what would the additive inverses of those be? Well, the opposite of 3/5 would be negative 3/5. Opposite of negative 5/11 would be positive 5/11. And the opposite of 4.5 would be negative 4.5, or I want to remind students that there are improper forms of all these things. So we'd get negative 9/2 would also be the same as the negative 4.5. Okay, just a word of note. I'm going to talk about this negative 3/5. Is there any other place we could stick the negative and still keep the value of that fraction the same? And the answer is yes. I could attach the negative to the 3, and it's not common, but I could actually attach the negative to the 5. All three of those are forms of the same fraction, and that's something that I wish more of my students had exposure to. They could kind of see for themselves how to push that negative in there. Okay, so let's look at what we define as subtraction with our various fraction rules. So if we have, say, common denominators, okay, so I would do a over b minus c over b. We would simply translate that to be a minus c over b. Okay, so 2/3 minus 1/3 would be 2 minus 1 over 3, which gives us 1/3. Would be one illustration of that. Then we want to look at not having common denominator. So let's say a over b minus c over d sort of goes back to that same rule we saw with addition. It's a times d minus c times b all over the product bd. So 2/3 minus 3/7 would be 2 times 7 minus 3 times 3 all over 3 times 7. So 14 minus 9 over 21, and that would be 5 over 21. So all of our earlier rules still apply. We just have negatives that we're bringing into this. Okay, so I want to do two sample problems that are a little bit more our speed as far as algebra skills go. So 2 minus x over 6 minus 3x plus 4 minus 2x over 3x minus 6. So we'll do that one for a practice problem, and then we'll do 2 over a plus b minus 2 over a minus b to illustrate that. Okay, so I'm going to ask you to pause this for a brief moment. Try it on your own first, and see if you can get it. And when you're ready, go ahead and start the video up again. Okay, so looking at that first fraction, I'm going to be a little suspicious of the fact that I can factor out something. I'm looking at 6 minus 3x and 3x minus 6. Man, they look opposites of each other. As a matter of fact, I'm going to factor out a negative from both numerator and denominator. So if I take a negative out of the numerator, I get x minus 2. And if I take one out of the denominator, I get 3x minus 6. Okay, now notice the two negatives are going to divide out, and I'm left with x minus 2 and 3x minus 6 in that first fraction. Well, now the two fractions have a common denominator, so I can add them together. So that'd be x minus 2 plus 4 minus 2x, and let's see, so it's negative x plus 2 and 3x minus 6. Okay, alright, so then look at that for a second. I'm like, you know, I think I can do that negative trick again, and I also notice that I can factor something out of the denominator. So I'm going to take a negative out of the numerator, which is going to leave me with x minus 2, and then I'm going to factor out 3, which is x minus 2 again. What do you notice? The x minus 2's divide out, and we're left with negative 1/3. Okay, so that's our first expression. That's our first answer. With the set of fractions that are in the second problem, I'm going to take advantage of that not common denominator rule. So 2 times a minus b minus 2 times a plus b all over a plus b times a minus b. Alright, well, what do we get up top? I'm going to distribute that, so 2a minus 2b minus 2a minus 2b. So I notice that. And in the denominator, I see that we have the difference of two squares pattern. So a squared minus b squared. Write that a so it doesn't look like a 9. Alright, so what do we have going up in the numerator? Like terms, the a's are gone. Leaves me with negative 4b up top and a squared minus b squared. So that would be our simplest form. Okay, so the last thing we'll look at in this particular section is estimation skills. And let me start by defining a couple terms. Sometimes when we look at rounding fractions, we want to use what are called convenient or benchmark fractions. Okay, so these are things where I round to say maybe a half because it's conveniently easy to think of adding a half or subtracting a half or multiplying by half of something. Maybe I want to round something to 3/4, or maybe I just round it up to 1, round it up to the nearest whole number, and estimate it in that fashion. Okay, so let me give us a couple problems that will demonstrate some earlier estimation techniques with this idea of benchmarking, or benchmark fractions or convenient fractions. So let's take 27/13 plus 10/9, and then let's do like something that's got a little bit of teeth to it. So 3 7/8 plus 11.5 plus 2 2/5 plus 5 1/16. Okay. So thinking about 27/13, well, 27/13, if it was 26/13, that's kind of close to 2. So I'm going to pretend that number's 2, and 10/9 is a little bit more than 9/9, so it's a little bit more than 1. So my estimate would be 3, and it would be an underestimate because both numbers are slightly bigger than the number I picked to round it to. But anyway, so that's kind of that works, as I picked something close that was easy to think about in my head. Okay, so let's look at 3 and 7/8. 3 and 7/8, I might want to use the technique of grouping, because I'm going to group 3 and 7/8 and 5 and a 16th. 7/8 and a 16th, like 7/8 is almost a whole, and 1/16 is a little bit more than 5, right? So if I take something that's almost 4 and something that's close to 5 and group those together, I get 9 out of it for an estimate. And then if I look at those two numbers, 11 1/2 and 2 1/2, well, the 2/5 is kind of close to a half. It's a little bit smaller than that, but I can kind of treat that as 2 1/2. So 2 1/2. Okay, so 2 1/2 plus 11 1/2. So the half from 11 1/2 makes that 3. So 3 plus 11 puts it at 14. And so 9 plus 14 would be 23. So I would estimate that when I add those three numbers together, I'd get something close to 23. Okay. But that's kind of how that works, is you look for easy fractions that you can get close together and then estimate them using previous techniques that we've seen in earlier sections.